For each positive integer n, let s sub n denote the sum of the digits of n. How many values of n is n plus 1 plus s of n plus s of n equal to 2007? Do we understand the question? Let's say n is 1, 2, 3, 4. What they mean by s of n is they're adding each digit. So what they would do, say that is the case, then what they want to do is they see these 1, 2, 3, 4 as individual numbers. So 1 is no longer 1000. It's just being added as 1. So let me show you what it looks like. So you in Mathematica, it's called integer digits. So of n, then you get this listing of it. And if you add them up, each one is called total. What would that be? 1 plus 2 plus 3 plus 4. That is 10. So that's how it becomes here. So that I don't have to type it over and over, I will just put all of them in one shot here. Okay, so you will get just one answer. If the number is 1, 2, 3, 4, you get the sum is this. Now, because I'm going to use this often, I will define a function called s. S of n is equal to, it's exactly this. So all I have to do is say s of, say, 1, 2, 3, 4, and then it will tell me the total. Very nice, right? Okay, that's what that s of n is in this problem. What is s of n? Well, then you're adding the digits one more time. So if I did this, I will be adding 1 with 0, so therefore I get 1. So if I have some horrendous numbers like that, this would be that. So basically you add all the digits first, right? Like this. You get 37. And then when you add 3 and 7, you get 10. That's what this function is. Okay, good enough. But here's something that you should know is about the property of 9, the modulus 9. Modulus 9, the remainder of, when you divide by 9, it will stay the same no matter whether you went through this s of n or not. I will show you what I mean by that. Suppose I have n equals, let's come up with a number. I will just pick an arbitrary number here. That's the number. Okay, so if I divide that n by 9, let's see what kind of remainder I get. Remainder is 5. What I want to tell you is that here, if I do s of n and modulus 9, the answer is the same. It will be 5. And if I did it again, modulus of, this time, s of n, and you see what you get when you divide by 9, it is still 5. It doesn't matter how many times I do, it will just remain 5 all the way. It doesn't matter what the number was. For example, let's have some other number. How's that? So there's a big number. If I divide that by 9, what's my remainder? It says it's 8. So what would be the remainder? It's 8. It's 8 all the way. What was that number anyway? Let's see. S of n, what was it? 53. So if you divide this by 9, you will get a remainder of 8. And what is s of? Do we need to do this? We know it's going to be 8, right? 5 plus 3 is 8. So if we divide that by 9, it is 8. So 9 has the property, same thing with 3, that if you divide by 9, then it doesn't matter whether you added all the digits, and if you add all the digits of all the digits added, it still would give you the same remainder.